All right. Day 2 of 1.8, continue modeling with quadratics. We're going to look at some physics examples with an object in motion and how gravity would affect that object. Okay, and looking at specifically a couple examples where a ball is moving through the air. First piece right here, the x squared term has to do with our effect of gravity. Okay, we got to pay attention to our units. Gravity is 9.8 in meters. It's got squared units, which is why it relates to a quadratic. 9.8 meters per second squared, and in feet, roughly 32 feet. Okay, we want this leading coefficient to be negative because an object in motion should go up, reach its maximum height, and then eventually come back down. So we want a parabola that opens downward. That's why we want it to be negative. This represents the initial velocity. H sub O represents the initial height. Those two things will typically be given to us. Okay? It's very important to be able to look at these problems and think about what is the question asking? All right? That's kind of where the context can get tricky, and it's where students can struggle. One of the first questions we're going to look at is to find the maximum height of a ball that's been thrown. That is a question about finding the graph's vertex. Now, in that question, it won't ask you to find the vertex. You won't see that word anywhere. You've got to kind of relate it to what we've done to figure out that if we want to find the maximum height of the ball, that's really a question about the vertex, okay? Which is different from a homework assignment where we're just practicing some skills and the instructions say, hey, here's a quadratic equation. Go find its vertex. Okay, well then you have to, kind of think about what am I supposed to find. In modeling problems, you have to think about that. Okay, it doesn't tell you which component you need to relate it to. Okay? Let's think about this example. Ooh, obviously an outdated PowerPoint here. Christian Ponder. We should switch that to Teddy Bridgewater. No, wait, he's hurt, isn't he? I think the Vikes played yesterday. I couldn't even tell you who started at quarterback for him. That's not good. Not good for me to admit that, and not good for the Vikes. Not good. Anyway, a Vikings quarterback. How about that? With the carousel that position has been lately. Throws a football with an upward velocity of 18 meters per second at a starting height of 2 meters. Okay? Find height in terms of time. H of t. This is asking us to find the equation. All right, notice the units are in meters, so I want negative 4.9. Remember, I want half of 9.8. Negative 4.9 t squared plus my initial velocity plus my starting height. Okay? That quadratic right there is going to model the height compared to time for this particular throw. When did the football hit the ground? Okay? This is exactly what I was talking about earlier. When did it hit the ground? The key here is to recognize this is a question about finding x-intercepts. Okay? Got my starting height of 2. Ball goes up. Gravity acts on it, comes back down. Okay? It's a question about finding where that point is, which is an x-intercept. But you see here, it just says when does the football hit the ground. There's nothing in there that says, hey, go find this equation's x-intercept. That's the type of thing when we're applying quadratics to real-life situations. That's up to us. We have to make that connection to what that question's asking. Now we have a couple different options to find x-intercepts. We could factor, though that does not look promising here, even though that's typically my first choice because it's usually the fastest and most efficient, but as far as factoring goes, this is kind of freaking me out. Negative 4.9. We have not practiced once how to factor a quadratic that has a decimal coefficient, and we're not going to start now. We're just going to go ahead and say, for us right now, factoring this really isn't an option. We need to go to an alternative method, which we have. It's a little bit more work, but it's way more reliable. The quadratic formula, it always comes back. Okay, it just keeps coming back again and again. It's a great way to find x-intercepts. Okay, Quadratic formula says that the opposite of b, which is negative 18, plus or minus the square root of 18 squared minus 4 times a times c all over 2 times a. If we can simplify that all the way down to, well, this is actually an interesting point. Simplify it down to 2 answers. We've got some thinking to do because I'm pretty sure we just want one answer, okay? When did the football hit the ground? How much time in seconds went by before the ball hit the ground? I want one answer, but this equation is actually going to yield 2 answers, which means one of them I want and the other I don't, okay? I'm going to start by simplifying what's under the square root sign. You can certainly take a minute to look at that yourself. That huge mess simplifies to 363.2, and this is all over 9.8. Okay? Now when I take this, now at this point I should recognize here that we have practice finding exact answers with the quadratic formula. As soon as we get this decimal going on in there, we kind of have to say, okay, a decimal approximation is going to have to do. We've not once practiced how to simplify a square root that has a decimal, and we're not going to start to do that now. It's possible to do, but we're not going to do it. All right, this is just a situation where we'd have to say a decimal will do. All right, that roughly simplifies to 19.06. Okay, over negative 9.8. Now I need to go down here a little bit to get a little extra space, get some breathing room here. I've got negative 18 minus 19.06 over negative 9.8. That's one of my answers. And I've got negative 18 plus 19.06 over negative 9.8. All right. One of these is the actual amount of time it will take for the ball to hit the ground. The other's garbage, and I don't want it. Okay? And you'll see this is very common, that the red flag for the one that I don't want is there's something about that answer that just simply doesn't make sense. It's not consistent with the context of the problem. Over here, okay, as I look at these numbers, I see I've got negative 18 plus 19. That would simplify to about 1.06. And before I even divide those numbers, I can see I've got a positive number on the top and a negative number on the bottom. I know that it's going to be a small decimal, like 0.2, 0.25, something like that. But it's going to be negative because I've got a positive divided by a negative. All right? I don't exactly know how much time is going to go by before this ball hits the ground, but I know I don't want an answer that's negative. Okay? That just doesn't make any sense. Now, if I compare that to here, I subtract what's on the top, 18 minus 19.06. Okay? I get negative 37.06 over negative 9.8. That seems a little bit better. Okay? A negative divided by a negative. That's positive, which is good because I want my answer to be positive. And then when I actually divide these numbers out, let me erase this just for the sake of space. I get about 3.78 seconds, which, you know what? That seems about right. Pretty reasonable for an NFL quarterback to heave the ball up in the air and have that ball stay up in the air for close to 4 seconds. It's a big-time throw, but we're talking about somebody with a big arm. It's positive. It's reasonable. That's the one I want. All right? Quadratic formula. It's a little bit of work to use, but it's oh so reliable. Unlike factoring, Always works. Next question. When does the ball reach its maximum height? Okay, again, the equation we're dealing with here is height compared to time is negative 4.9 t squared plus 18t plus 2. This is a question about the vertex. Okay? We have a couple different techniques that we've used to find the vertex. One is completing the square, but kind of like factoring, we never addressed a situation where this number right here was a decimal. And we're not going to do that at this point. We're going to say that completing the square is a nice, efficient option to use when it works, but it's not going to work. Okay? It's just not a good one for us to try to apply that technique to. We have another option. I know that the x-coordinate, or the value for time, is located at negative b over 2a. So negative 18 over 2 times negative 4.9, which comes out to be about 1.84. This is a value for time, so that's going to be in seconds. That's how much time would go by that's how long it would take for the ball to reach its maximum point. So here's an alternative method, kind of like the quadratic formula, though this isn't so bad. Negative b over 2a is pretty slick. A good way to find the vertex. Okay? And now once I have that, I can go back to my equation and say, all right, I'm going to plug in 1.84, because whatever I get for the y value, that's the height of the ball after 1.84 seconds, which I know at that time the ball is at its maximum height. So whatever h of 1.84 is, that is going to tell me the height that this ball reaches. Okay, now a little bit of number crunching here to do, but the concept of what we're doing isn't too bad, and we're just taking this value for t and substituting into our quadratic and evaluating. And just for you to be able to double check your answer, it comes out to be about 18.53 meters. Okay? This number seems reasonable. In fact, it seems very reasonable because it's between 0 and 3.78. That's something I needed to check for because the ball is thrown at 0 seconds. It hits the ground at 3.78. I got a number pretty close to halfway in between, which is right about what I was expecting. That's a really reasonable answer for when the ball reaches its maximum point. 18.5 meters, that's about 45, 50 feet. Actually, maybe more like 50 to 60. But again, reasonable number. Nothing crazy here, no negatives, nothing weird like that. These answers seem to make sense with the context of the problem. All right? That's all for 1.8 day 2. Again, the big key here is when you're reading a problem in a real-life context, which skill that we have practiced throughout this unit is it asking you to relate it to? Okay? That can take some thinking. All right? Maximum point, that was the key word for vertex. Stuff like that. Okay? Make note of any questions, and we'll talk about those more in class.